Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And I hope I am live. Let me check first. Yeah. So we'll begin the session today. I am Jeetendra Dixit. I did my BTech from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for last 11 years. All right. So before the beginning, let me tell you about the Unacademy subscription. So as you know, you can take Plus subscription on Unacademy, and another is Iconic subscription. So I'll tell you about both. First, Unacademy Plus subscription. So if you take Plus subscription, then you get access to daily live classes of all the educators who are teaching for Unacademy Plus. You can access to all live tests and quizzes. All right, and all these courses are well structured, and no matter how did you get the subscription, you can get unlimited access. Okay, so you can follow educators of your choice. You have complete freedom of that. Second is special classes are free, so you can attend the special classes on the platform completely free. So you'll get to know the feel of the platform. All right, like you can interact, you can ask your doubts, you can during the live sessions only. And these are the subscription charges. You can subscribe for 1 year and 2 years, and after 10% discount you'll have to pay only this much. All right, 1 and 2 years respectively, and my code is Jeet1. The next is Iconic subscription, in which you get personal coach. All right, and personal coach will guide you throughout your preparation for all the top exams. Your test analysis will be in a personalized manner. Your study planner will be customized, so everything is like uh, an expert's observation. All right, so like test preparation, study planner, your guidance throughout your preparation, everything will be given by an expert. So that is Iconic subscription, and it's okay. So that is of 50,000 and 86,000. All right, for 1 and 2 years respectively. You can download Unacademy's learning app from Play Store, and after downloading, you can start special classes. So calculus, I'll do indefinite into integral calculus today. I'll discuss integral calculus, but before that, I want to discuss Rolle's theorem. Okay, so some examples of Rolle's theorem, and we use concept of differential equations while solving some questions of Rolle's. Okay, so I'll tell you where do we use. Okay, so what is Rolle's theorem? Rolle's theorem says that if f is continuous in closed interval a to b. So let me give you the details of Rolle's theorem first of all. So it's a quick revision. If f is continuous in a closed interval a to b. Second point is f is differentiable in open interval a to b. And third point is f of a is equal to f of b. Then we say that f dash x is equal to 0, or f dash c is equal to c. Let's take c is equal to 0 for some c belonging to a to b, right? So that is Rolle's theorem. Now, sometimes in options, you have questions like this. Say f and g are differentiable functions such that f of a is equal to f of b is equal to 0. Then prove that f dash c into g of c plus f of c into g dash c is equal to 0. In this, it is very easy to figure it out that it's a derivative of f into g, right? So if I start with this function, let's say solution, if I take this function hx is equal to f of x into g of x, right? Then I can say that h of hx is a differentiable function because fx and gx are differentiable function, and because they are differentiable, so they must be continuous, right? And also we can easily say that h of a is equal to h of b is equal to 0 because f of a is equal to f of b is equal to 0. That means Rolle's theorem is applicable for this function hx in the interval a to b. All right. So then that means you can write h of h dash c is equal to 0 for some c belonging to a to b. All right. You can write like this. Now see, what is f dash c? What f dash c is nothing but this given expression, right? So you can write this. Now I have some questions, so I'll give you these questions first. Suppose f is a differentiable function and a and b are the roots of fx is equal to 0. A and b are the roots of fx is equal to 0, where a and b are more than 0. This is also given. A and b are more than 0. Then show that. My first question is, you need to show that f dash of c plus k times of, now k can be anything, it might be a constant, it might be some function also, k times of f of c is equal to 0. Okay, that is the main point, that is the main point. And based on this, there are many questions asked in this Rolle's theorem. All right, so we'll discuss this. I'll tell you the method first, you figure it out, how to prove it. Whose derivative is this basically? I'm telling you that we need to apply Rolle's theorem, but in which function we need to apply Rolle's theorem, that is the main point. Okay, so this concept I want to discuss, and we'll have to use one method of differential equations. If you have done, I'll give you the hint. Hmm. Just try to figure it out. One minute. Okay, so question is this. Uh, are you trying? Write in the comment box if Archana, today's session is general integral calculus and differential calculus. So, and because today we have most two sessions. So one is of differential calculus, another is of integral calculus. Tomorrow we'll continue some topic from tomorrow, day after tomorrow. So Pranav, you were asking about the solution. Are you there? Are you watching, Archana? Which class are you in? Okay. So I'll tell you the solution of this. So if you have any query, let me know. I'll start giving you the solution of this. See how to solve it, how to figure it out, whose derivative is this function. That is the main question of finding the solution of this. Okay, so this is a differential equation dy by dx plus some function fx. It might be some constant also, like k can be a function of x, fx into y. If this is written and we need to write we need to express this as an exact derivative of some function, then we multiply it by a factor. What is that factor? That factor is called integrating factor, and that integrating factor is nothing but e raised to integral of fx dx. All right, e raised to integral of fx dx. First of all, your expression should be of this form: dy by dx. This means y dash plus fx into y, all right, of this form. Once you have this kind of expression, then you can write this as an exact derivative of some function. And what is that exact derivative? Whose exact derivative is this? For that, you need to multiply this expression by e raised to integral of fx dx. Okay, if you multiply it by e raised to fx dx, then that will become e raised to integral of fx dx plus into y dash plus e raised to integral of fx dx into fx into y, right? And because it will be an equation, so right side also will multiply. Okay, so we are not concerned about that. We are concerned about this expression, which is written on the left side of the equation. Now you can see whose derivative is this. Whose derivative is this? This is actually the derivative of ddx of, or d of, you can write d of y into e raised to integral of fx dx. Okay, so for those who have not done in differential equation, it might look different, it might look difficult, but while solving it will be very easy. Okay, so once we'll take some examples, it will be easy. What we need to learn in this is that integrating factor is e raised to fx dx. And what is this fx? Fx is coefficient of y. Coefficient of y in this expression. It might be a constant, it might be a function of x. All right. So we need to write our expression in this form: y dash plus fx into y. Then we need to multiply this expression y by e raised to integral of fx dx. and after doing that it will become exact derivative of y into e raised to integral of fx dx. All right, you can see its derivative is this, like in this question. Okay, in this question if I multiply, what is the integrating factor? So first we'll figure out the integrating factor in this, and that is going to be e raised to integral of, now you can see coefficient, this is y, right? This is y and this is y dash. Fx is nothing but y, right? So integrating factor is e raised to k dx, because k is a constant in this, so it is going to be e raised to kx. All right, e raised to kx. Let's see. Now if I write this expression e raised to kx into fx, I'm replacing c by f. So f dash x plus k into e raised to kx into f of c. All right, into f of c. If I take this function as hx, I have copied this expression and I have also multiplied this expression by e raised to kx. And why did I multiply by e raised to kx? Because I know that this is the integrating factor. If I multiply this expression f dash x plus k fx by this integrating factor, it will become exact derivative of some function. All right. Now whose derivative is this? So this is our h dash x. I'm taking this as h dash x because I know this is the derivative of some function. So what is your hx? Now you can figure it out easily. So your hx is nothing but, see, whose derivative was this? This is derivative of, let me write x here. This is fx into e raised to kx. So if you differentiate fx into e raised to kx, like, you will get h dash x is equal to this, right? So now you need to start your question with this. All right, hx is your function. You check the Rolle's theorem whether it is applicable or not in this function. Yes, it is completely applicable because e raised to kx is continuous and differentiable function, and fx is also given continuous and differentiable function. H of a is equal to h of b is equal to 0 because f of a is equal to f of b is equal to 0. So you can write that h dash x is equal to 0. You can write h dash x is equal to 0. And if you write h dash x is equal to 0, it is going to be e raised to kx into f dash x plus k into e raised to kx fx, UV rule, all right, is equal to 0. Now you can divide by e raised to kx. Why? Because e raised to kx is not 0. So you can divide by e raised to kx. So after dividing by e raised to kx, you can write your f dash x plus k times of fx is equal to 0 for some x, belonging to your interval a to b. So I hope you have got it. Have you got it? Any doubt? Have you got it, Pranav? Waiting for your comment. All right. So now let's do some questions. Like, okay. So what you got it, got it. Okay. Now what you need to do? Uh, let's quickly do these examples. Suppose I can make infinite number of questions on this. If you are clear with this method, then you can figure it out easily whose derivative is this. All right. So let's take this example: c into f dash x plus 3 into f of c. The same question, fx is continuous and differentiable. Same question, fx is continuous and differentiable, and f of a is equal to f of b is equal to 0, and a and b are positive. All right, a and b are positive. Now we need to prove that this is equal to 0. Okay, so let's check it. We can write f dash x first of all, right? We'll write this equation as fx plus 3 upon x. I'm replacing c by x. All right, I'm replacing c by x in this. and also dividing by x because x is a positive number. C belongs to A to B. Okay, this is what we need to prove. C belongs to A to B, and C, A and B are positive numbers, so C is also a positive number. So we need to prove this. Okay, we need to prove this. Same question, fx is a continuous and differentiable function. F of A is equal to f of B is equal to 0, and A and B are positive. Okay, so now what is the integrating factor in this? So let's do it. Integrating factor is e raised to integral of 3 upon x dx. Now that is e raised to, what is the integration of 1 upon x? That is ln x. So 3 ln x. Now it is going to be e raised to ln x cube. Now that is going to be x cube. All right. Now it is going to be x cube. So we need to multiply this whole equation by x cube. Multiply it, okay? And take that as h dash x. So h dash x is equal to x cube f dash x plus 3 times of x square fx. All right, this is your h dash x. Now you can figure it out easily. What is the hx? So hx is going to be, now differentiate this. So it is going to be 3x square. No, sorry. You need to write antiderivative. This is already the derivative. You need to write the antiderivative. So whose antiderivative is this? X cube into f of x. So this is your hx. Now we have got the hx. You can see h dash x is nothing but this, right? So now just check whether Rolle's theorem is applicable in this function or not. Yes, of course, Rolle's theorem is applicable because h of a is equal to h of b is equal to 0, right? Because f of a is equal to f of b is equal to 0. And x cube is completely continuous and differentiable function for all x, right? So it will be continuous and differentiable for a to b also. Fx is already given continuous and differentiable function, right? So we can write h dash x is equal to 0 for some x belonging to a to b, right? And then you can write this function which is written here, this one, x cube into f dash x plus, apply UV rule, 3x square f of x is equal to 0. You can take c also in place of x for some x belonging to a to b, right? For some x belonging to a to b. Now you can divide by x square because x is not 0. Because x is not 0, that's why I have given you that a and b are positive number. So a to b, that interval b will be the interval of positive numbers, and because x lies in that interval, so x will also be positive, non-zero, right? So you can divide by x square, and after dividing you can write this f dash x plus 3fx is equal to 0. So if you want apply this integrating factor method, then sometimes it might be lengthy for you to figure it out whose derivative is this, because you have already divided by x square. If you write the complete expression like this, then perhaps it will be easy for you, because you can divide by x square, and after dividing you can simplify the expression and write it in this way. Then it becomes difficult. Okay, so then you use this this method. Mhm. fx is twice differentiable function. F of a is equal to f of a is equal to 0. F of b is equal to, this is small b actually, a b c d. By mistake it is written capital B. So this is the small b. F of b is small c and small d. All right. So these some values are given. A is greater than b, A is less than b, is less than c, is less than d, is less than e. So in this order, and then the gx is given. Then minimum number of zeros of gx. That is the question. This is another very good question of Rolle's theorem. So you need to first figure out what is this gx actually. Gx is equal to f dash x the whole square plus this very important expression. I think 2-3 times they have asked question based on expression like this, f double dash x. So it is f dash x whole square plus fx into f double dash x. It seems that it might be a derivative of something. Whose derivative is this? F dash x, right? You can see if hx is fx into f dash, then h dash will be f into f double dash plus f dash into f dash, that is f dash square, right? All right. So gx is nothing but the derivative of h function, and now this is your h. So you have got h. All right. Now see how to find the minimum derivative if hx is a differentiable function using Rolle's theorem, right? If we have three roots a, b, and c of hx, then we can say there will be at least one root between a and b and at least one root between b and c also. There might be more than one. Okay, so that's why we say at least one root, because graph can be like this also. Graph can be like this also, right? So in this you can see h dash will have more than one roots, but between a and b there will be at least one root, and between b and c there will be at least one root. Okay, so if I keep generalizing it, then I can say that if hx has n different roots, if hx has n different roots, okay, say a1, a2, a3, and so on up to an, these are the n different roots of hx, and hx is a differentiable function, then there will be at least n minus 1, at least n minus 1 roots of which function? H dash x. Okay, so that is statement we can say using Rolle's theorem. If, what is the statement? I'm writing it here. If hx is a differentiable function in some interval a to b, and continuous in closed interval a to b, and hx is equal to 0, has n distinct roots. Distinct, why am I saying distinct? Because between two distinct you'll get one root of h dash. So n distinct roots in a to b. All right, then we can say using Rolle's theorem that h dash x is equal to 0 will have at least n minus 1 roots. All right, because if you have three roots of hx, then between first two you'll have at least one, and between next two you'll have one. Okay, so you'll have at least two. Okay, there might be more than also, but we can say that there are at least two roots. So similarly in this case we can say there will be at least n minus 1 roots between a and b. I hope you have got it. So we are going to use this point. Okay, we are going to use this point to solve this question. Now this information is given. What is this information? See, this question is very beautiful question, because in this question you need to use Rolle's theorem as well as intermediate value theorem. What is intermediate value theorem? So intermediate value theorem says that if fx is a continuous function and it has values of opposite signs at 2 points, then there will be at least one root of fx is equal to 0, right? So you can see at a is a root of f, right? A is a root of f, so f of a is given 0. F of b is given 2. So f of b is given 2, so graph will be somewhere here, positive. F of c is given minus 1. That means graph will cross x-axis between b and c, because value has become negative using intermediate value theorem. Now f of d is plus 2. So again, the value at c is negative and value at d is positive. So it will again cross the x-axis at D. Now it is 2. Now f of E is 0 again. Okay, so f of E is 0. So you can see how many roots are there of hx between A and B, between including A and E. So we can say hx has, sorry, not hx, fx. It's rough sketch of fx. So we can say fx has at least, no, not at least, sorry. Yeah, at least actually, sorry. So at least 1, 2, 3, and 4. Okay, at least 4 roots. There might be more also. At least 4 roots in A to E, including A and E, I'm saying, right? A to E, between A and E. Now, what about F dash? How many roots F dash will have? F dash has at least 3 roots. You can see, right? 1, 2, and 3. And these 3 roots will be distinct from the roots of fx. Okay, because one root occurs between A and this root. Okay, between, beach mein. All right. So similarly, we'll have at least 3 roots. Now I'm putting this open interval A to E because A and E I'm not considering. Okay, between A and E there will be 3 roots, and these 3 roots will be distinct from the 4 roots of fx. If you multiply fx and f dash x, so how many roots fx and f dash will have? Fx and f dash x will have? You need to add these roots, right? 4 roots of this function and 3 roots of this function. So total, now you will have 7 roots. When you multiply 2 functions, the roots will add up, all right, if they are distinct. So hx will have at least 7 roots. Now we have got that this function has 7 roots, at least 7 roots, right? At least 7 roots. Now, because this function has at least 7 roots, so its derivative will have at least 6 roots, right? Because we need to figure out the roots of this function, okay? First, we are identifying the roots of hx. Now, we are finally talking about the roots of h dash x. So, we have got that hx will have at least 7 roots, all right, in A to E, including A and E, all right? And h dash x will have 6 roots between A and E, all right? So, this h dash x will have, using Rolle's theorem, you can say, will have 6 roots in A to E. This was the question. I hope you have got it. Okay. So this is another type of question they ask. So this was about Rolle's theorem. I hope you understood these examples. Just let me know by commenting or by messaging me. Okay. So now let's discuss some questions. Let's practice some questions of indefinite integration. So in this, I'll continue indefinite integration. So this is a sum. Let's do it. See, in this 3 functions, tan 2x, tan 4x, and tan 6x are in product. Now look at the relation between the angles. So you can see this is theta 1 or 2x. This is 4x, which is say theta 2. And this third angle is basically 6x, which is nothing but theta 1 plus theta 2. Okay, so that is the biggest hint. So you first simplify this trigonometric expression. I mean, you need to split like you do with algebraic functions. You do partial fractions. In this also, you need to segregate these functions which are in product. How to do that? You need to start with this formula. Tan of 6x is equal to tan of 4x plus 2x. All right. Then you apply this tan of 4x, tan of A plus tan of B divided by 1 minus tan of A tan of B, all right, like this. Now you cross multiply. So cross multiply, you'll get this tan of 6x minus this term which we were looking for, tan 2x into tan 4x into tan 6x, all right, is equal to, it is tan of 4x plus tan of 2x. So now you can segregate this. So you can write this tan of 2x into tan of 4x into tan of 6x is equal to nothing but tan of 6x minus tan of 4x minus tan of 2x, all right, like this. Okay, so put in this and integrate it easily. Now it is tan of 6x minus tan of 4x minus tan of 2x dx. And if you integrate it, it is going to be, what is the integration of tan? It is sec of 6x divided by 6 minus sec of 4x ln of 6x whole divided by 6, all right, whole divided by 6 minus ln of sec of 4x whole divided by 4 minus ln of uh, sec of 2x whole divided by 2, right, plus c. And you can see 12 was there in the product, so you need to multiply this whole expression by 12 as well, right? And 12c is same as c, so just leave this c, leave this c. Now if you multiply by 12, then it will be 2 ln sec 6x, and 2 you can take inside, so it is going to be ln of sec square of 6x minus, if you multiply this 12 to second term, it is going to be 3 ln, so that you can write ln of sec cube of 4x, and third term is going to be, this is going to be 6, all right, so ln of sec of power 6 2x, all right. Now you can club these terms of ln, so it is going to be ln of a minus b minus c is ln a upon bc, all right. So ln of sec of square 6x divided by sec cube of 4x into sec 6 of 2x, all right, plus c. So this was the question. It's pretty easy. Now solve it. This is also easy problem. All right, so let's do it. First of all, you can write, there's a very technical important point in this question. Cos square, you can write cos 2x, you can write cos square x minus sin square x, all right, first thing. Yeah, I think now it is perfect. Hmm. Okay, so now let's do it. This problem, this one. So now, okay, so take cos common. If you take cos common, it is going to be mod cos x, okay, outside. So mod cos x can be plus cos x or minus cos x because interval is not given, so you'll have to take both the cases, all right? So first, I'll write cos x into mod of cos x and under root of this will become 1 minus tan square x. Now there will be two scenarios in which first case when cos x is positive. So if interval is given like 0 x belongs to 0 to pi by 2, you can write cos x is positive. So you'll take this case. If x belongs to like pi by 2 to pi, then you'll have to take cos x mod of cos x is minus cos x. Okay, so that will be the second case. So if it is plus cos x, then what is the answer? Then this will become cos square. Take this to the numerator. It is going to be sec square x dx, and in denominator it is 1 minus tan square. So if you put tan x is equal to t, it is f dash x upon 1 minus fx square. So directly you can write sine inverse of fx. Fx means tan x plus c. So that is the answer. And second scenario, when cos x is negative, it is going to be the integral of minus of, okay, because mod of cos x is minus cos x. So minus sign will appear. Sec square of x dx divided by under root of 1 minus tan square x, and this tan again you can write the same formula. So in this case answer is going to be minus of sine inverse of tan x plus c. I hope you've got it. So which options are correct? It's a multiple correct type, so A is correct, okay, and D is certainly correct, and C is also correct because minus of sine inverse can be written as pi by 2 minus cos inverse. So it is going to be cos inverse of sin x plus some other constant. All right, so cos inverse. This option is also C. C and D are same actually. C and D are same. So I hope you've got it. Now let's do this one. All right, so in this case, this one is easy. Listen. You can take x square common from the numerator. It is going to be 1 minus 1 upon x square. And in denominator also you can take x square common. So it is going to be x square plus 1 upon x square plus 3. All right. This x square will get cancelled. And you can see 1 minus 1 upon x square is derivative of x plus 1 upon x. So it is going to be 1 minus 1 upon x square divided by x plus 1 upon x the whole square plus 1, alright, because x minus 1 upon x square is the derivative of x plus 1 upon x. So now you can put x plus 1 upon x is equal to t, or you can directly apply the formula. What formula you need to apply? It is f dash x upon fx whole square plus 1, so it will be tan inverse of x plus 1 upon x, alright. So tan inverse of x plus 1 upon x, this is one of the answer. Now it can also be written as cot inverse of minus of cot inverse of x plus 1 upon x, all right. So what is the function? You can define this function in many ways, like your gx can be x plus 1 upon x, All right. In fact, your gx can be minus x. If you take this minus inside, we can take my. Can you take this minus inside? No, you can't take, right? In tan you can take, but in cot inverse you can't take. All right. So this gx will be x plus 1 upon x only, right? Gx will be x plus 1 upon x. Yeah, your f function might change. F function might be minus cot inverse or tan inverse. That you can do. So if you take gx is equal to x plus 1 upon x, then what do you need? First of all, you need f inverse. Okay, f will be, in this case, f will be tan inverse, right? If we compare with this, all right? So f will be tan inverse, then tan x will be your f inverse function, all right? You need f g of f inverse. So g of f inverse is basically, put this f inverse is tan x. So put in this, you will get tan x plus 1 upon tan x, which is basically, if you simplify it, is going to be 2 cosec 2x. Okay, just convert this into sine and cos and you'll get the answer. So we'll continue differential calculus in our next session. All right. So this was about Rolle's theorem, how to apply differential calculus concept in Rolle's theorem. That was the main point, and some few questions of integral calculus. We'll continue that in our next session. All right. So take care, everyone. Take care. Subscribe the channel and use my code JEET1 if you're getting this. If you're taking this